Hello again, everybody, and welcome back. Today we're going to be talking about a dependent samples t-test. Now, in one of the prior presentations, we talked about the independent samples t-test, and I'm not going to spend a lot of time talking about why we would use one over the other. That falls a little bit outside the scope of the video, but just to be very brief, when we talk about independent samples t-test, we're really talking about the idea of whether or not the variables should be dependent on one another per se. In other words, are they associated? Should they be correlated somehow? And with the independent samples t-test, we assume no. So when we talk about things like age and sex, age and race, many of these other examples that we could talk about, we expect that these are going to be different. They're going to be separate. In other words, that the individuals, each row, is ultimately going to be independent of one another. With the dependent samples t-test, however, what we're talking about is this idea that there should be, or we expect there will be, an association between the variables. In other words, to some extent, whether it is the same measure, maybe measured at more than one point in time, or whether or not they are the same measures, but are getting at a similar pattern or similar idea within an individual. So we expect that we can't treat them as being necessarily completely unrelated. Now, this is an important consideration for us to take into account because ultimately how the calculation of the test statistic between these different types of t-test, independent versus dependent, is done very differently. If you go back and look at the formulas, for example, an independent samples t-test is going to look at the mean comparison between group A and group B, for example. And ultimately, it doesn't matter what group A or group B you're referring to, just simply the mean of those groups. When we talk about the dependent samples t-test, which is the focus today, we're going to be talking about not the difference between the means, but the difference between the scores for each individual separately. Now, when we look at something like this, and you can see on the screen right now, I've got the SPSS file open. This is fictional data. This is not real data. I mean, some of it is, but I've added a couple variables here just to be clear to make things a little bit easier to look at. So I'm going to pull this open a little bit. And you can see here we've got a number of variables. This is actually information about students. You can see we've got things like type of school. We have demographics like female, race, socioeconomic status. We've got scores such as reading, writing, math, science, and social studies. And I've also added here two scores, which I just created for ease of making sort of a point here, which I'm calling reading and writing scores at time 2. And again, completely fictionalized scores, but I wanted to be able to make some demonstrations. Now, because these are ultimately all getting at the idea of educational attainment in terms of those scores, then very likely we're going to assume that for each student, these scores may be dependent on one another. So we're not going to say, by the way, that one is a perfect correlation to the other. We expect that students who do well in one are going to do potentially better in others as well, as compared to folks who are going to do worse in them. So we can run a dependent samples t-test looking at the relationship between things like the reading and writing, or the reading and math, or the writing and math, and so on down the line. Or we can also think of it as almost a pre-test, post-test comparison, right? Which is the idea of scores at time 1 versus scores at time 2. And so again, you can see we've got reading score, and then I've introduced the reading at time 2 as well as the writing at time 2. All right, I think you all get the point here. I'm going to just move right on to the demonstration. Now, one thing to remember is that within SPSS, they actually don't have a dependent samples t-test. Instead, if you go to Analyze, Compared Means, you're actually going to see almost at the bottom something called the Paired Samples t-test. And it is the same thing. A Paired Samples t-test is, in fact, a dependent samples t-test. So let's open that up. Now, I'm going to move this a little bit in the middle so that we can see the variable names up here on the left, while at the same time we're looking at the Paired Samples t-test control panel. Now, I can go through and I can click one variable and move it over. And you can see what happens is it just sticks it right there into variable 1, pair 1. Now, notice, by the way, that the OK is grayed out. I've only given it one score, so it doesn't have enough information at this time to determine whether or not what the reading is going to be compared to. So for this example, I'm going to make things simple. I'm simply going to click the writing variable over here on the left, and move that through. Now, the default that the program's always going to assume is that you know what order these are supposed to be in. So that 1 and 2 have been, first 1 and 2 that you've selected are ones you want to pair up. The other option you have, by the way, is if I reset this, is I can always go and say reading, and then down here at the bottom where I have reading at time 2, if I highlight both, and I do that by holding the control key down, if I bring them both over at the same time, it immediately pairs them up as well. Or, again, like I said, I can click them over separately as well. So let's start with my first example with the reading and writing. Now, my research hypothesis is going to be that there seems to be a relationship between these variables. And if there's a direction to it, that's fine. We're not going to worry about that because ultimately, either way, the program is going to run the analysis. Now, notice I don't really have any other information that I need to provide it. Once I've given it that second variable, OK has become ungrayed. In other words, it is now something I can click. If I go to options, there's actually not much here. All that I can tell the program is what the confidence interval percentage should be. In other words, what's the alpha associated or what's the error level associated with the confidence interval. And at the end of the day, for what we're talking about today, it doesn't really matter all that much. Bootstrapping is something that falls a little bit beyond our discussion, so we're not going to worry about that today. So with this in mind, I'm simply going to say OK. And you can see here we get the output. And right away, you can see at the very top, you can see that the average score is 52.23 for the reading and 52.775 for the writing. Now remember, the research hypothesis is that these variables are going to be related. Now bear in mind as well that those group means, while interesting, aren't really what's being tested here. What's being tested here is the pairing of the scores of the individuals within each. Now again, we're reported things like the number of respondents, the standard deviation, and the standard error of the mean. Coming down here to the paired samples correlation, we're not surprised that there is a correlation between the reading and the writing score. It's a positive correlation and it's statistically significant, suggesting that people who scored higher on reading are going to score higher on writing. People who scored lower on reading are going to score lower on writing. Really kind of validating our decision to treat this as a dependent samples t-test, although no necessity. Coming down here, you can see that the mean difference between these groups is going to be about negative 0.5. Well, we saw that up here, right? Just kind of eyeballing, we saw there wasn't a big difference here. Coming down here, we have our standard deviation, standard error. The confidence interval is being reported. And then finally, the piece that we're the most interested in, which is the t-statistic. Now again, if we were to treat this with an alpha of 0.05 as a t-distribution with an n greater than 120, we would be looking for a normal cutoff excuse me, of 1.96 or negative 1.96. You can see right away that this t-test statistic has not exceeded that value. And so we also, looking at the significance value, can see that it's failed to fall below that 0.05 cutoff we look at. So ultimately, while these are correlated to one another, all right, we're ultimately going to say that we're not really seeing much difference between these values. So, and again, we kind of eyeballed that here as well. There wasn't a large difference. But ultimately, if we were to think about this in terms of whether or not individuals are doing much better or much worse on one versus the other, we failed to find support for that idea here. We reject the idea, we failed to reject this idea. And ultimately, at the end of the day, we have to go with the null hypothesis here, right? That there is really no difference between the scores on one group versus the other. Now, I'm going to close this, and we're going to run one more dependent samples t-test here. And this time, sorry about that, I'm going to reset this, and I'm going to go with the reading at time 1 and the reading at time 2. Now, we might want to do a study like this because we think, for example, that we've introduced maybe some sort of new reading program. Maybe once one of the measures is collected in a prior year, the second is collected in the following year. The expectation is that we would expect that people's skills or scores should have gone up over that time period. So with that in mind, our hypothesis is going to be ultimately, in this case, that there's going to be a pattern here, that there's going to be a difference, right? We're comparing means, so we're saying that there should in fact be a difference between these two groups, between time 1 and time 2. I'm going to hit OK. And you can see in this case that once again, we have a reading score at time 1 of 52. Reading score at time 2 is about 62. Now, even before we look at the statistics, that's a pretty big jump. It makes me think that we are going to ultimately reject the null hypothesis, suggesting that there's no difference, right? That there's no relationship. We can see that we've got a very strong correlation here, and bear in mind I said before this is fictional data. I put this in to make sure we'd have a very good example. Statistically significant. Coming down here, we see that mean difference of 9.8, which again, reflected by what we saw up here at the top. And most importantly, we get over to the t-score of negative 66. So again, with an alpha of 0.05, our cutoff value should have been 1.96. We've far exceeded that 1.96, negative 1.96 criteria for our critical value. We're going to reject the null hypothesis. Clearly, the scores are statistically significantly greater at time 2 than they were at time 1. And ultimately, that's it. That's what a dependent samples t-test does, or a paired samples t-test, as SPSS refers to it, does for us. It allows us to look for and hypothesize about there being a mean difference, right? A difference between these scores, between, in this case with the dependent samples t-test, between either two dependent scores or one score measured at two different points in time. All right. Ultimately, that's about all there is in regards to this. As always, if there are any questions or you want any clarifications, please don't hesitate to let me know. Have a great day.